All right, page 384, section 5.2. We are looking at verifying trig identities. This is the exact same thing that we have been doing with the simplifying in section 5.1. There were some of those that we had to verify too, right? So it's the same thing. We're going to use the exact same steps that we've been using. So step number 1, we're going to look for Pythagorean identities. That's a trig function squared. If we see 2 trig functions squared, or we see a trig function squared with a 1, that's almost always one of those Pythagorean identities. We put that first on our list because that makes the biggest impact on our simplifying or verifying. If we happen to have one of those, it'll make the equation, well, not really equation, but it'll make the problem that we're working with break down so much faster than anything else. So we put that first on our list. All right, then second, we're going to look for fractions. See if you can combine them with a common denominator or break them apart into 2 separate pieces and simplify. Number 3, see if you can factor. And that's where a lot of times we'll substitute out the trig identity, like we'll replace sine with x, or replace tangent with y, or replace secant with z, or something else, and see if that helps us get an idea of how to factor. And then we said if all of those things fail, we'll change everything to terms of sine and cosine. We want to do that after we try the other stuff, because if there's a short way to do the problem and a long way to do the problem, that's almost always the longer, harder way. Then we said, bottom line, do something. If you just sit there and stare at it, nothing is going to happen. But if you start trying to plug some identities in or start working with it, sometimes it falls together and you don't even see it coming. We are also going to add another thing on the bottom of that list, and it is cheat. So we're going to add another thing to the bottom of our list, and it is cheat. And we'll talk about that as we work our way through here. Okay, so let's look at example number 1. Example number 1, we've got secant squared minus 1 over secant squared, and we're trying to verify that that's equal to sine squared. All right, so let's start at the top of our list. Look for Pythagorean identities. I have a trig function squared and a 1, so flashing lights should start going off. That almost has to be one of my Pythagoreans. So if I look back on page 376, what is secant squared minus 1 equal to?
Tangent squared.
Tangent squared. So I'm going to replace secant squared with tangent squared. Thank you, Caitlin and Bryce. And divide that by secant squared. All right. Step number 2. I come back over here and say, okay, look for Pythagorean identities. I don't want to replace these with the Pythagorean identity. That's like undoing what I just did. I don't want to go backwards. I don't have a fraction that I can combine because it's already combined. I can't really see a way to factor this because this would kind of be like x squared over y squared. I don't know what I would do with that. So I'm going to change everything to terms of sine and cosine. So what's tangent in terms of sine and cosine? All right, so tangent is sine squared over cosine squared. And then we can say secant squared. Secant in terms of sine and cosine is 1 over cosine squared. Remember that when you divide fractions, you multiply by the reciprocal. So instead of dividing by 1 over cosine, let's turn that around and multiply it by cosine over 1. Now, you don't have to write these as 2 separate steps. I just don't ever want to confuse anybody by skipping a step. So if you go straight from here to here, that's perfectly fine. All right, so now we've got sine squared over cosine squared times cosine squared over 1. And so when we multiply, our cosine squareds will drop out, and that'll just leave us with sine squared. And that's what we were trying to get to. So again, I don't have to come over here and write sine squared all the way down, but notice that we only worked on one side. We worked on the left-hand side. So when I'm doing a verify, I can only work on one side of the equation until I get it to equal the other side. Now, we've talked also about these, that there are multiple ways of doing these problems. There doesn't have to be like one set way to do it. There are other ways that you can do these. So let's take that same problem that we just did and let's redo it a different way, okay? Maybe when you first looked at this problem, you said, ooh, secant squared over secant squared. I can cancel that out. Well, I can't cancel things that are being added and subtracted. I can only cancel things that are being multiplied or divided. It'd be kind of like if I had 4 minus 1 over 4. I know that 4 minus 1 over 4 is 3/4, but if I canceled those 4s, I'd get negative 1 over 1, right? You can't cancel things that are being added and subtracted. They won't give you the right answer. The only way I can cancel is if I have something that's being multiplied. So in step number 2, we've talked about combining fractions with a common denominator, but we've never had an example of this breaking fractions apart thing. Here's what we're talking about when we say break fractions apart. What I could do is take this take this numerator and break it up over my common denominator into 2 separate pieces. So that's what we mean by breaking apart our fractions. You can see if I put this back together again over that common denominator, that's the same thing as what we had in the step above. Now I have secant squared over secant squared. That I could cancel and just get 1. And 1 over secant is cosine, so 1 over secant squared would be cosine squared. So if I start back up at the top of my list looking for Pythagoreans, I have a trig function squared and a 1. That's almost always one of our Pythagoreans, right? So what's 1 minus cosine squared? Sine squared, right. And so that's another way of working that problem. Gives me the right answer. You know, we have options. All right, look at the next one. Look at example 2. This little guy right here that, you're like, wait, why is there a fish in the middle of my problem? That's just a Greek letter. Anytime that they give you, an alpha or a beta or a theta or something that bothers you, if you'd rather replace them all with x's or replace them all with thetas, you can. You don't have to use the variable that's in there. But so in this case, we've got 1 over 1 minus sine plus 1 over 1 plus sine is equal to 2 secant squared. That's what we're trying to verify. All right, so let's start at the top of our list. Do we have any Pythagoreans? Do you have anything squared? Yes? No? No. So no Pythagoreans. Do we have fractions that we could combine or break apart? Yeah. So let's try that. So let's get a common denominator. I would need 1 minus sine and 1 plus sine. So let's get our common denominator. For that first fraction, we had 1 minus sine in the denominator, and we had to multiply it by 1 plus sine. So whatever I do to the bottom, I have to do to the top, right? I'll have to multiply my numerator by 1 plus sine as well. For the second fraction, I had 1 plus sine down here. I multiplied it by 1 minus sine, so whatever I do to the bottom, I also have to do to the top, so I need to multiply the top by 1 minus sine. The purpose of getting a common denominator is to combine our fractions with that common denominator, right? So let's rewrite this over that common denominator of 1 minus sine, 1 plus sine. And if I combine my numerators, I have 1 plus sine plus 1 minus sine. So plus sine and minus sine drop each other out, right? And 1 and 1 would give us 2. All right. So I look at my list and I say, okay, look for Pythagorean identities. I don't have anything squared. Combine or break apart fractions, just did that. Factor, no, nothing I can factor. It's already factored down here. Change everything to terms of sine and cosine. It is already in terms of sine and cosine. So remember, if you ever get stuck, you have a couple of options. What bothers us are these trig functions. So we've talked about substitute them out. If I substitute them out in my denominator down here, I would have 1 minus x times 1 plus x. In a normal problem, if you saw 1 minus x times 1 plus x and it said simplify, what would you automatically do? FOIL, right. So that's what I want to do here as well. And, that might help it dawn on me that that's the way that I want to go. So let's FOIL this together. 1 times 1 is 1. 1 times sine and negative sine times 1 is going to give me a positive sine and negative sine that drop out. And then negative sine times positive sine is negative sine squared. So just a difference of squares, right? All right, go back to the top of my list again. Do I have any trig functions squared? Yes. So what is 1 minus sine squared? Cosine squared, right. So now I've got 2 over cosine squared. And that would be, yes, 2 secant squared. And that's what I was trying to prove. All right, we added another step to the bottom of our list of suggestions of things that we could do. And the thing that we added was cheat. All right. How many of you, when you were little kids, you had like the fun pad and it had the little maze in it, and like the mouse was at the top of the maze and the cheese was at the bottom of the maze, and you're supposed to get them connected, right? Yes? Come on, I'm not the only one, right? Okay. Now, how many of you started with the mouse and you got as far as you possibly could until you got stuck? And then you went down to the cheese and you brought the cheese up and then you made your two lines meet. Come on, all you cheaters. Here we go. Absolutely, that's what I did. I could never make my way through that maze. We can cheat on these problems the exact same way. We are only allowed to work on one side of these. Sometimes it'd be so nice if I could come over here and say, okay, secant squared, I know that's 1 over cosine squared. And, oh, hey, once I get down here where it's 2 over cosine squared, I would have them equal to each other. It'd be nice if I could work on both sides of the equation until I got them to equal. I can't do that, but I kind of can if I take my answer and I move it down to the very bottom and I start working my way up. Let's say that you got right here and you got stuck. I think that'd be a really easy place. We went through all of our steps. There was nothing else to do. It'd be really easy to just kind of get stumped right here and not know what to do. So let's say if you quit right here and you put a great big question mark on your test, you're missing half of that proof, right? So you're going to lose half credit. You're easy going to lose 3 points, 4 points, something like that on that problem because you don't have the last half of it. Instead, take your answer, bring it down here to the bottom and write it as the last line. I just picked up a free point, right? I mean, honestly, you could get a free point on every single problem on the test just by writing your answer down at the bottom of the proof, right? We'll take it. So then I start working my way up and I say, okay, I know that secant is 1 over cosine, so that would be 2 over cosine squared. Now look, if I had worked my way down to here and got stuck and I came down here and did that, now I'm just missing one line. We're talking about a -1 on that problem, right? Instead of it being halfway wrong. The other thing about that is if I'm looking at this and I'm looking at this, I can say, okay, I got my numerator right, like 2 is already there, but somehow this is supposed to become cosine squared. How in the world would that be cosine squared? Well, cosine squared is 1 minus sine squared. Oh, if I FOIL that together, it's 1 minus sine squared. So sometimes being able to see where you're going can give you a clue of how to get there. Okay, so another suggestion then is just start at the bottom, put our answer at the bottom, and work our way up from the bottom. Okay? All right, let's look at another one. Example number 3. All right, so you tell me what to do here. We've been doing these a couple of days, so give me suggestions.
We can replace the trig.
Okay? Ryan says replace the trig. He's absolutely right. We got tan squared plus 1 is secant squared. All right? We also could replace this trig, cosine squared x minus 1, with its Pythagorean identity, but we're going to have to turn it around a little bit. All right? We've got that identity that says sine squared plus cosine squared is equal to 1. What I need is cosine squared minus 1. So let's take this 1 and subtract it over to the other side. So now I've got sine squared plus cosine squared minus 1 equals 0. That's what I need right there, cosine squared minus 1. I need to get rid of this sine squared then. So let's subtract that over to the other side. So cosine squared minus 1 will be negative sine squared. So remember, those identities work just like an equation. You can turn them around a myriad of different ways. All right, so now what?
You can make secant squared 1 over cosine.
All right, I can make secant squared 1 over cosine, Bryce says. Why is that? Okay, well, if I go through my steps, I can't do Pythagoreans. I don't have fractions. I can't factor. I mean, this would be like x squared times negative y squared, right? I don't know what to do with that. So our next step is change everything to terms of sine and cosine. So absolutely, let's rewrite secant as 1 over cosine. So secant squared would be 1 over cosine squared. Sine was already in terms of sine and cosine, so we got negative sine squared. All right, now what?
Multiply.
Okay, so if I multiply, I'm going to have negative sine squared over cosine squared. Then what?
It equals negative tan squared.
It equals negative tangent squared. Exactly. I'm done, and I don't even realize it. Okay? So sometimes they fall together without me even seeing it coming. So that's why we say try something. Keep going through those steps. Be persistent. Write something down. I can give you partial credit if you write something down, and sometimes it'll work itself out without you seeing it coming. Okay, so here is our homework for tonight on pages 389 to 390. We're doing 1, 5, 9, 21, 25, 31, 37, challenge 43. And remember that we've got our quiz tomorrow over 5.1 and 5.2. All right, such a deal I have for you. So for our quiz tomorrow, I understand this is one of the hardest things that we do. So for your quiz tomorrow, on page 376, we had a box of identities. Most of those identities we have known since page 300. They have been on the past couple of tests and quizzes. We should know those inside and out. Actually, the only new thing that we added were the even and odd identities, so we only added like 6 new things. All right? So on your quiz tomorrow, I am only going to give you 3 problems to do from sections 5.1 and 5.2. I can't give you a verify because that would give you the answer, right? So if we're talking about multiple choice, I'm either going to have to give you a simplify or a factor or something like that, okay? Only going to give you 3 of those. Everything else that I'm going to give you is going to be a matching section of formulas from that box on page 376. So you are guaranteed, if you just memorize, you pass, right? And then all you have to do is get 1 right and you've got a B, and get 2 right and you've got an A, and keep going from there. Okay? So I know that these are really hard. That's our deal.